Hello everyone, Assalamu alaikum. Welcome back to my channel. First things first, go ahead and subscribe to my channel if you haven't already to get in touch with my latest content. In today's video, we are kicking off our VLSI Systems Lab series by diving into Xilinx Vivado and Nexys A7 FPGA board. If you are new to FPGA development or just need a refresher, you are in the right place. So let's get started. Now, this lab or this video is all about familiarizing yourself with the tools that we will be using throughout the course. By the end of this session, you'll have a solid understanding of how to set up Xilinx Vivado, create a simple project, and implement a basic logic gate on Nexys A7 FPGA. Now, before we dive into our design, let's take a quick look at the hardware that we will be using today. This is the Nexys A7 FPGA board. So this is a powerful and versatile platform for digital circuit design, ideal for both beginners and advanced users. Now let's talk about the insides, what's in this package, in this FPGA chip. So at the heart of this Nexys A7 is the Xilinx RTX 7 FPGA, specifically the XC7A100T. This chip offers 15,850 logic slices, each containing 4 6-input LUTs and 8 flip-flops, making it a perfect for a wide range of projects from simple logic gates to complex digital systems. Now let's talk about the memory. The board features 15,850 kilobytes of block RAM, which is useful for storing data and instructions for your FPGA designs. It also includes an 8 MB quad SPI flash memory for storing bit streams and configurations. That we will cover a little bit as well. Now in I/O options, this package comes with variety of I/O options. It has 16 switches and 16 LEDs, which are great for basic input and output for basic projects. There are also 7-segment displays, as you can see, and RGB LEDs and push buttons. In addition, it has a VGA port allowing you to interact with your design in multiple ways. In expansions, for more advanced designs, this board offers several PMOD connectors. These allow you to connect peripherals with your for added functionality like sensors or communication modules. For power supply, as you can see, for this board, it has for this board can be powered via USB, and this USB cable is provided with the package, so you can power it up using this USB, and this same USB is also used for programming and communication with the FPGA. Now for this Nexys A7 is easy with onboard USB JTAG circuitry. This allows you to directly upload your bit stream from Xilinx Vivado without needing any external hardware. So overall, Nexys A7 is a feature-rich and accessible platform for FPGA development, providing everything you need to get started with digital design. Now that we have an idea of what this board can do, let's see it in action in our first lab video series. Now let's get Xilinx Vivado up and running. If you haven't installed it yet, head over to Xilinx website and download the latest version. Once you have installed it, open the software and you'll be greeted by Vivado welcome screen. Now go ahead and click on create new project. This will start the project creation wizard. Next, give your project a name and choose a location to save it. Make sure to select REL project as the project type, and don't forget to tick the box that says do not specify sources at this time. Now it's time to select your target device. We'll be using Nexys A7 FPGA, so make sure to choose the correct part number, which is XC7A100TC SG324-1. Now with our project setup, let's design a simple logic gate. We'll start with a basic NOT gate. Let me walk you through the steps. Now, in the flow navigator on the left, go to add sources and then add or create design sources. Click create file, name it something like NotGate or whatever suits your project that you're working on, and select Verilog as file type. Now in the code editor, let's write the Verilog code for NotGate. Once you have written the code, save the file and we are ready to move on to the next step. Now the next step is to link your code to your hardware, and for that we use this constraints file. Let me write some code in the constraints file. In simpler terms, the constraint file contains the board's onboard switches, LEDs, or whatever peripherals that you want to use and links them to your code. So in this case, I will be using switch 0 and LED 0, and for that these are the codes for switch 0 on my onboard switch 0 and LED 0. Now that this is complete, save it, and we are ready to move on to the implementation. Now that our design is ready, it's time to synthesize and implement it on the Nexys A7 board. In the flow navigator, click on Run Synthesis. Vivado will analyze your code and create a netlist. Once synthesis is complete, move on to Run Implementation. This step maps your design to the physical resources on the FPGA, like we did in the constraints file. After implementation, generate the bit stream by clicking Generate Bitstream. This is the file you'll use to program the FPGA. Now, with our bit stream ready, let's program the Nexys A7 board. The first step is to connect your board to your computer using a USB cable. Next, you have to open Hardware Manager and click on Open Target to connect your FPGA. And don't forget to turn it on. Once connected, click on Program Device and select the bitstream file we just created. Vivado will upload the bitstream file to your FPGA and your design will be live on Nexys A7. Now it's time to test it. To test our NOT gate, we'll connect a switch to the inputs that we have specified on the constraint file, and we need an LED that we specified on that constraint file. So let me flip the switches and see and observe what the behavior of LED is. Now, as we know that if the switch is on, then our LED will be off, and if our switch is off, then our LED should be on. This is the basic functionality of NOT gate. And there you have it. We have successfully set up Xilinx Vivado, designed a simple NOT gate, and implemented it on Nexys A7 FPGA. This is just the beginning of our journey into VLSI design. In the next lab, we'll dive deeper into more complex circuits, so stay tuned. And don't forget to like, subscribe, and hit the bell icon so you can never miss an update. If you have any questions, drop them in the comment box below. Thanks for watching and see you in the next video.